we're going to jump right into 4.1 on page 79. This chapter is all about polynomials. Okay? Well, let's see how much you actually know. I want you to start on 1 through 4 on page 79. Work with your groupies. Do the best you can. Well, so there are a couple things that you need to have down in term, and I'll try to help summarize this at the end. But first, you need to know what a polynomial is. So, polynomial. Emily? It has multiple terms, yes. Okay? Polynomial has multiple terms, yeah. Okay, and it could have a variety of degrees. Okay? So, that means in order to do that, we also need to know what degrees are. Okay, well, let's talk about this. First, this is a polynomial. Notice the power here. You have a 2, a 4, you have a first power, and you have a constant. Okay, please note that all your powers, or excuse me, all your variables are in the numerator position. Whereas this one is not a polynomial. You actually have an x in the denominator position. This is called a rational function. This is not a polynomial. This is actually called a rational function. Rational, not irrational. Okay? This one is a polynomial because the x is radical. If it was, it would be a square root function. Okay? This is a polynomial function as well. So 1, 3, and 4 are all polynomials. If so, write it in standard form. Standard form means you put your largest degree first. So f of x equals, that's a negative 3x to the 4th plus 2x squared plus 6x plus 1. This is already in standard form. And this one right here, p of x, what would go first? Okay, very good. All right, the degree of this, now this book likes us to actually name it by 4th degree. We call it, it's a 4th degree because we look at the degree of the variable. Okay, the highest degree. A 4th degree we call a quartic. Okay, so it's called a quartic, and I think, no, I don't see it. Quartic. This right here, we're not worrying about degree, but here, this is one you're very familiar with. Its degree is called, what do we call it when it's first power? Starts linear. Okay, what do we call the degree when it is squared? Quadratic. Now, we have covered all the special names with the exception of one. We haven't done a 3rd degree. A 3rd degree we would call cubic. Cubic. If it was 5th degree or 6th degree, we'll just call it 5th degree or 6th degree. I'm sure there are. I'm not looking them up. Okay. 5th degree and 6th degree is what we'll call them. From there, in terms of the type of polynomial, that's what that means, the type of polynomial. You count up how many terms there are after you've simplified it. There's 1, 2, 3, 4 terms. We will just call that a polynomial with 4 terms. Okay, now, if there are 2 terms, like on this one, we will call that a binomial. Bi meaning 2. If there are 3 terms, we call it a trinomial. Tri meaning 3. Now, what if there's only 1 term? One term we call a monomial. A monomial. Hey, one other thing in terms of degree. One other thing in terms of degree. If you have a 0 degree, meaning x is gone, and it's just like y equals 2 or 7, that is called a constant. I didn't give myself a lot of room to work there, but that is called a constant. Okay? Constant is where you just have a constant term. Okay? No x's. All right. Any questions there? Leading coefficient. What is the leading coefficient in this? Yeah, Kai? The leading coefficient is -3.
You need to move that over.
Thank you. Hey, the leading coefficient is the number attached to the variable with the highest power. It's called your leading coefficient. Okay, what is your leading coefficient in number 3? 15. And the leading coefficient here? -2. No, we're talking about this -2. Yeah. Good call. Okay, any questions? Why don't you try number 5 and 6 with your groupies? Okay, just to make sure you know what you're doing it correctly, there is number 5. -18. Please note, when I substitute, I'm putting it inside parentheses. That way I don't make mistakes. This is negative the quantity 2 cubed, which means 2 times 2 times 2 times -1. Insert inside parentheses. Okay, the next one is our hero, 0.
Oh, McCoy, that's really cool.
Okay. Hey, you guys, the mistake that's generally made here when you're dealing with substitution, make sure that you are doing -4 to the second and then multiplying by 32. Okay, do your exponent and then times the outside value. Those of you that do 32 times -4 and then square it, you're getting some messed up large number right there. Okay? Any questions on those two? Okay, I want you to go ahead and take a break from that. Go ahead and take your note page and turn it over. On the back of the note page, you have this. What I'd like you to do is get that stuff into your graphing calculator. We will call this y sub 1, 2, 3, 4, and 5. You may want to, well, go ahead and get them in there first, and we'll talk. All right, now once you get those plugged in, it may be helpful to turn on only one plot at a time so you actually know what you're talking. And when it says number of x-intercepts, remember that's how many times it crosses the x-axis. The in behavior, however, let's say I have a graph that looks like this. I go, all right, really ugly graph, okay? It wouldn't be pointy and weird like that, but really what we're looking for in end behavior is we are focusing on everything that is on the ends. That means I am focusing on just that part and that part. The end behavior is down, up. That's it. That's all I want to know. I mean, in this case, I would have 1, 2, 3, 4, 5 x-intercepts, which is the other piece you're looking at. But for end behavior, you're going down, up. Okay? So, make sure you're filling this guy out right here. So if you guys graphed any of these and you had to zoom in any way other than your standard viewing window, then you inputted it incorrectly. You inputted it incorrectly? I know. That's really hard to say. All right. So, as I'm going through this, this is x to the first power. How many x-intercepts? X to the second power, how many x-intercepts? X cubed had how many? X to the fourth had how many?
4.
And x to the fifth had how many? 5. So what could we conclude, based at least upon this, what could we reason about x-intercepts and the degree of our polynomial? The highest degree is the amount of x-intercepts you what? Key word on this next word here. The highest degree is the number of x-intercepts you could possibly have. Right? It's not necessarily how many you have. In this it is. But we know with a quadratic, we know it could have 2 x-intercepts. You guys have studied those. Okay? A quadratic could have that. A quadratic could have that. No x-intercepts. It also could have 1 x-intercept. Okay? So you could potentially have 2. You could have up to 2. You could have up to 3 with a third degree. You can have up to 4 with 4 degree. With a 120th degree, you can have up to 120.
Wait, what would happen if you put that in our calculator?
Well, you'd have to be able to find it first. Like, it might not be on your standard viewing window. But you could have a lot of x-intercepts. Now, here's a question. Could a linear ever have 0 x-intercepts? What was the end behavior of linear? This one. Down, up. What was the end behavior of this one? No, the third power. Down, up. How about the fifth power? Down, up. What do you know about the odd powers? They're all down, up. Okay. Could you ever have 0 x-intercepts on an odd? No, because it starts down and ends up. Right? If it starts at the bottom and ends at the top, it has to cross once, unless it just hops over it. Okay, which polynomials will not do. Okay? Rational functions will. Polynomials will. Okay? This right here was even, and it was up, up. And this one was even, and it was up, up. So even degrees go the same direction. Odd degrees go in odd directions. Different directions. Okay? That is kind of odd. Okay, now please note my leading coefficient here. Hey, pay close attention. Leading coefficient is what? What is my leading coefficient each time? It's 1. What type of 1? It's a positive 1. That's the most important piece. It's a positive number. Because if my leading coefficient now becomes negative, everything flips. If it was negative, this now would be up, down. This would now be down, down. We know that with the parabola. If you have a negative, it goes upside down. This one would be up, down. This would be down, down. And this would be up, down. Think of it in terms of like slope of a line, right? If you can always think back to like a linear function, the slope of a line, if it's a negative slope, it just looks like this. It starts up and ends down. Okay? That's what happens when you have a negative coefficient. It's falling from left to right. Okay. Any questions there? All right. Summarize to your neighbor what you have learned so far today. Back up here. Okay, first a couple questions that I heard walking around. First, what's the fundamental theorem of algebra? Okay, we can estimate how many x-intercepts there are based upon your degree, which is just what we talked about here. There's at most 2 because x is squared. Okay, our degree of the polynomial is 3, so there's at most 3 x-intercepts. That's all we're talking about down here. That's number 1. Number 2, this sheet that I just gave you, this is a note page. Okay, it's just kind of going through everything I think we went through today. Okay, just to kind of summarize, and I'm going to give you some different notation that you may want to add down here in a minute because your book does that. And then you don't have to use it. It's yours. It's up to you. Okay? So what I'd like you to do right now, I want you to take a look at problems 7, 8, and 9 back on page 79 of your student journal. I want you to go ahead and work with your groupies. Answer those questions there. Here we go. Number 7. There, got it. Describe the end behavior. It is down, down. Now, please note the notation you're going to see in your book is f of x goes from negative infinity. So f of x approaches negative infinity as x approaches negative infinity. Or you may see it, the other way to think about it is, I'm going to write it up here. Okay, this is in the note page I just gave you. Now, you guys, really on our assignments for this class, I am fine if you say down, down. But you will also be reading your textbook, and you will be advancing to another level of math where they're going to expect that you know what's happening. When you're describing your function, this is saying as x is going from, as x goes to negative infinity, I like to think of it in terms of x first. Oops, that's negative infinity. Y approaches negative infinity. So for those of you like, okay, that didn't really help me at all, based upon what you just said a second ago, still doesn't help me. Okay, well, let me get this next one in. This one would be as x approaches negative infinity. Okay, y would be approaching positive infinity. Okay? All right, now let me point out on both of these, I have only given half the statement. Okay? So let me try to draw out what I have on each of these. So first one, on the bottom part. So let me try to just get the bottom piece up here. On that piece right there, what I'm saying is that on an x-axis, let's actually just focus on the x-axis for a minute. Here's my x-axis. You guys, one thing in math, I know that you're very smart in math. That's how you made it this far. But one thing that may help you is to start realizing that your x-axis and y-axis are two different measuring sticks. Okay, so here is your x-axis. It's a measure. It's like a ruler laid horizontally. Okay, and your y-axis is a ruler laid vertically. All right. So as x approaches negative infinity, that means it goes towards the negative end. As you, from 0, as you increase in the negative direction, y is increasing also in the negative direction. So if I draw in my y-axis, y is also increasing in the negative direction. That's what this arrow right here is saying. Right, that's the down part. Okay, so the other down part is over here. So which one changed? The x did. Now we're saying as x approaches positive infinity, y approaches negative infinity. Okay? So with that being said, if that's the case for this one, I want you to complete the statement up here for this one. We have the first part, that's dead for this branch over here. If it helps, draw the picture for yourself. So let me maybe switch it up. Okay, so there's negative infinity to positive infinity. So if I'm going up, up, which one changed this time? X changed? Anything else change? Nope, just X. So as X, oops, that's supposed to be as, should have used a pencil. X approaches infinity. Y approaches infinity. Okay. How many think you got it? Okay. So that's the more mathematical approach rather than saying, yeah, it's up, up. The up, up is the quick way to write it. Okay. I'll let you, if you want, fill out these bottom ones. I'm not going to fill that in right now. Okay? I might put it up there at the end of class if you want to see. All right? Number 8, down, up. By the way, there's the answer for the down, up one. Except for I have the y first here, or the f of x. So I have it kind of flipped around. And then number 9 is odd. It's odd because it's going in opposite directions. Negative because it's going down. It starts up here and goes down. So if you think of it as slope, it's falling from left to right. Yeah. Your assignment. Here we go. Take a look at it. You're not doing every single bit of this, but this part right here, estimate the x-intercepts. We're going to do probably tomorrow as a class, so you do not have to do that right now. If we do it tomorrow using the sheet, we may not even use the sheet on it.
Wait,
okay?
what about the y-intercepts?
You have to do the y-intercepts, and the y-intercepts should be easy. Y-intercept, x-intercepts when y is 0. Y-intercept is when x is 0. So if you're looking at 1, if x is 0, that disappears, and that disappears. It's always your constant. What if there isn't a constant?
0.
Yeah, then it's 0. Okay? Y-intercept should be easy. All right, and describe the end behavior. All you have to do is say down, up. I don't expect you to put it in the notation with infinity. You can if you want. Yes? Yep. Drawing the arrows would be fine. Okay, turn it over, please. On the back. On the back, we are not doing this one because we don't have to predict about the year 2000 anymore because well, some of us lived through it. Some of you did not. That's very sad. This is from our old textbook, by the way. That's why we got a new textbook. When we were making predictions about things that happened before you were born. All right?
I wonder what happened then.
Yes. Next. Down here, you must do this. You need to do all of these, and please note that it says write it in standard form first. You cannot figure out its degree and the number of terms until you write it in standard form. I guess you could figure out the degree, but the number of terms you don't know. You can't classify it. So when we this becomes y equals 5x plus 2. That goes from a trinomial now to a binomial. You're classifying that. Okay? All right. For those of you who wanted the end of that, the rest of that, there are the other classifications if you wanted to check how you did.
Yeah, that was nice.
Amazingly cool.